electricity or launch a rocket.
That's the higher bar. Human technological capability seems to have required a very rare combination. Not just high intelligence, but also fine manipulative appendages, like hands with opposable thumbs.
Handy are those thumbs.
Very handy. Also a terrestrial environment and highly evolved social structures that promote the accumulation and transmission of knowledge across generations. Therefore, the true value of phi may depend on the probability of this specific suite of traits evolving together.
So smart might be common, but tech smart might be rare.
That's a tension. This highlights a fundamental tension in the equation's biological terms. The evidence suggests life may start easily and quickly, but the path to our kind of technological intelligence appears to be exceptionally long and arduous.
This brings us to the final two variables of the Drake equation, Fc and L, which take us completely out of astrophysics and biology and squarely into the realm of pure speculation.
Dear guesswork, almost.
Here we're talking about the sociology, the psychology, and the ultimate fate of hypothetical alien civilizations.
These factors are governed by choices, by behaviors, and by existential pressures that are almost entirely unknowable to us. While the preceding terms set the stage, these final two determine whether any actors will actually be on that cosmic stage when we look, and crucially, for how long their performance will last.
The real unknowns.
This is truly the realm of the unknown, based on what we can only guess about alien psychology and societal trajectories.
Let's delve into Funiwasi, the fraction of intelligent civilizations that develop technology that releases detectable signs of their existence into space.
Do they broadcast?
The Drake equation, conceived in the early days of radio astronomy, carries an inherent fundamental assumption that electromagnetic radiation, specifically radio waves, is the primary means of interstellar communication.
And this assumption might very well be a form of technological chauvinism. Why should advanced civilizations still be using what, to them, might be considered primitive radio waves?
Maybe they're using something else entirely.
Exactly.
Yeah.
They might have progressed to communication methods that are far more efficient, far more secure, or simply far more subtle, and thus completely undetectable to us with our current technology.
Like what?
We could be talking about technologies we can only theorize about, such as directed neutrino beams or quantum entanglement communication, or even methods entirely beyond our current scientific understanding, beyond the very laws of physics as we know them.
Wow, things we can't even imagine.
Or maybe they just prioritize efficiency, using highly directional low-power signals between specific targets, rather than broadcasting omnidirectionally into the void, making eavesdropping nearly impossible.
Like a focused laser beam instead of a floodlight.
Precisely. And beyond just technology, there are compelling sociological and psychological reasons why an advanced civilization might choose not to communicate, even if it possesses the means.
Why would they stay quiet?
Well, a low value for FISI could be the result of deliberate, galaxy-wide policy. One intriguing idea is the cosmic zoo hypothesis,
Ah, the zoo hypothesis.
which posits that advanced civilizations are aware of us, they know we're here, but they observe from a distance without interference, treating Earth as a protected nature reserve or a scientific experiment.
Like Star Trek's Prime Directive.
Sort of, yeah. A far more ominous explanation, gaining traction in recent years, is the dark forest hypothesis, drawn from the chilling science fiction of author Cixin Liu.
That one sounds scary.
It is. This theory suggests that the galaxy is not a welcoming open community, but rather a dark forest, filled with silent, potentially hostile hunters. In this scenario, broadcasting one's location, making your presence known, is a fatal strategic error, risking attracting the attention of hostile, more advanced civilizations.
So silence is survival.
The only rational survival strategy, therefore, is to remain silent and perhaps eliminate any other life that reveals itself. If this grim logic holds true, efficacy would be effectively zero for any civilization that manages to survive for long. It's a truly chilling thought.
Or perhaps they just don't care about us at all. An advanced civilization might simply not be interested in interstellar communication.
Maybe space is boring to them.
As technology advances, as societies evolve, the allure of inner space, creating incredibly complex virtual realities, exploring the nature of consciousness, or pursuing hyper-efficient resource management within their own system might become far more compelling and resource-efficient than the slow, difficult, and potentially pointless task of shouting into the cosmic void for millions of years.
Given these myriad, deeply speculative possibilities, estimates for FC are almost pure conjecture. The original Green Bank meeting, in its boundless optimism, suggested a value of 0.1 to 0.2
1 in 5 to 1 in 10 broadcasts?
Right. But as our source material points out, this is little more than a guess, entirely contingent on unknowable alien psychology, motivations, and technological paths.
Okay, FC is a huge question mark. And finally, we arrive at L, the average lifetime in years of a technological civilization in its communicative phase.
How long do they last?
This term is arguably the most powerful and certainly the most sobering in the entire Drake equation. While the preceding fractional terms can only reduce the final number, L is a multiplier that can span an immense range from a few decades to billions of years.
It has huge leverage.
Its value has an almost tyrannical power over the final answer.
Its value can swing the final estimate for n by many orders of magnitude. In fact, given the overwhelming uncertainties in the other fractions, the original Green Bank meeting famously concluded that, as a rough approximation, n is roughly equal to L.
N equals L. Wow.
This profound insight means that the number of civilizations we might detect at any given time is overwhelmingly dominated by how long they typically manage to last once they reach a communicative stage.
And what limits this longevity? Ultimately, it's a civilization's ability to navigate existential risks.
The big threats.
Those threats that could cause its premature extinction or the permanent, irreversible collapse of its potential for future development. Researchers have extensively categorized these risks, giving us a grim but necessary framework for understanding the challenges that may set the upper limit on L.
We can broadly divide them into natural risks and self-inflicted risks. Natural risks include threats from the cosmos and our own planet, like supervolcano eruptions, large asteroid impacts, nearby supernovae, or gamma-ray bursts.
Things from outside or below?
Right. While these events can be utterly catastrophic, the probability of them causing the complete extinction of a technologically advanced species is generally considered to be relatively low compared to the threats they create for themselves.
We're our own worst enemy.
It often seems that way. It's often the intelligent species itself that poses the greatest danger.
That's truly the chilling part, isn't it? The consensus among risk researchers is that the greatest threats to a technological civilization are precisely the ones it creates itself.
Intelligence creates power, power creates risk.
The very intelligence and technological prowess that allows a species to develop interstellar communication also grants it the unparalleled power of self-annihilation. The primary anthropogenic or self-inflicted existential risks, when you delve into them, are deeply unsettling.
First, nuclear war. Despite the end of the Cold War, this remains an incredibly potent existential threat. An all-out nuclear exchange could still trigger a catastrophic nuclear winter, leading to global agricultural collapse, mass starvation,
The end of civilization.
and the potential end of civilization as we know it, even if some humans survive the initial blasts. It's a self-inflicted wound we've narrowly avoided.